So I'm going to make this relatively quick. I'm going to show the second assignment. First of all, a little trick. This is the assignment that I recorded last time, the solution. So I'm going to simply copy this because of the header, and I don't want to have to do the header again. So I'm going to copy that into array temperature analysis.org, and then I will simply delete all this other stuff. And I'm ready to go. So I'm going to save the general instructions here. Going to give you the program itself. Basically, you had to analyze weekly temperature data, compute the maximum, the minimum, averages, and modify temperatures. And the array size was supposed to be fixed at 7 elements for daily temperatures of 1 week. So I'm going to make it even simpler for myself. Just going to create a code block here. And in the code block, I'm going to start with a header, which I have copied already from somewhere. And from my sample solution, I'm going to put this in here. And this is version 1 without user input. So I'm going to set the values of the input temperatures instead of getting them via user input. I'm going to start with sort of a little bit of pseudocode, just giving the general sections of the program. So I need to declare constant array size. I need to declare an array to hold the temperature. Declare other variables. And then use a loop to display the temperatures. This was explicitly asked in the instruction. Then find highest and lowest temperature using selection statements, and then calculate the average temperature. Loop. And I think that's almost it. Here another loop to count the days above average using a loop and a conditional statement. And lastly, modify the array by adding 2 degrees to each temperature. So this shows basically the requests that I had made for the final solution. We're just going to fill this in bit by bit, and I leave it to you then to create version 2 with user input. That just means you have to add a section with scanf. So let's do this. Declare constant array size. That's a preprocessor directive. Declare an array to hold the temperature, and I'm going to turn this into a floating array because temperatures are not typically integers. And this is an array of size 7 days of the week. And we can just put some temperatures in here, which I've already recorded here. So I'm going to just put them in here like that. Yeah. Now, remember, you type a line that should compile, make it compile. So I'm just going to run this, and the code produced no output. There's no printing statement, but there's also no error provided by the compiler. Now, what other variables do we need? We need a loop counter because we're going to use for to go through the array elements, and we have a number of variables to hold the different output variables. So I should probably put in here, if you want it to be complete, you would put in what the input is and what the output is. Okay. If I have time, I'm going to do this later, but I wanted to keep this recording under 20 minutes if possible. So, temperature array. Actually, I'm going to put it in here anyway. Float. Temperature array float and max, min, average. I should say highest, lowest, average temperature, and there was something else, number of days above average temperature, and temperatures increased by 2 degrees. Okay. So we were declaring other variables, the loop variable, then we need a maximum, we need a minimum, we need the average, and we need the sum. To compute the average, it's useful to set the sum to 0. Then we need an integer for the days above average. We're also going to set to 0. All right? So that's the variables. And I think are pretty clear why we need them. Now we're going to use a loop to display the temperatures, which basically just means printing out this array. So we already have a loop variable, so let's make a little header for that. So temperatures Monday to Sunday, and then for I equals 0, I smaller size, I plus plus. We want to print f. And now the formatter is G. We could use F if we wanted to and be more specific, but G is a floating point format that simply picks the best format depending on the input. So in this case, it will print all the variables to 1 decimal digit accuracy. And that's it here. So we're going to print temp of I. Close the print statement, semicolon, and this should also run. So we're going to see what happens. Oh, there's a problem. Yes, I wrote print Python style and not printf. I run that again. I get the temperatures Monday to Sunday. Oops. Introduced a mistake. So that's pretty much it. Now there's a problem again here with the formatting. That's a little weird actually. Oh, because I forgot in the header, I forgot results output. Now I have to run this again. And now it should work. There we are. Okay, let's get on. Getting more difficult. Now find the highest and lowest temperature. First of all, we're going to initialize the minimum and the maximum to the first element of our array. So the idea of this algorithm, it's almost not fair to call it an algorithm, is that we pick an element of the array which is automatically minimum and maximum if all the array elements are the same, minimum and maximum stays at that value. As soon as we encounter, as we go through the array, a number that's smaller, we're going to replace min by that number. If we find a number that's greater than max, we replace max by that number. And that's all that needs to be done. And for that, you only need a loop, and inside the loop, you need selection statements. So let's do that. So minimum equal max equal temp of 0, the first element. That is, if we run through the array from 0, which is customary. Of course, we could run through it from any direction. And then we're going to just take this loop. I'm going to make it a little easier to read, actually. Take this loop, copy it, because we know it works. And in this case, we have more than one line that follows. The first if statement is if the array element we're just picking, temp of I, is smaller than the minimum, then replace the minimum by that element. And otherwise, move on and keep the minimum at the existing element. And if the temperature of the ith element is greater than max, do the same thing for the max element. Okay. Close the for loop, Control-Alt / to indent. Indent doesn't actually work very well. And you can see why. If the indenting doesn't work like this, what it means is that we've fallen into Python mode again and forgotten the closing semicolons. So you can see every time this works a little better. And on the last one, if all the code is fine, pre-compilation, the syntax Emacs will actually help me make sure that the for loop is correct. Okay, so now I can run this, and there's no mistake. There's no output here, but at least the syntax is correct. We may still have logical mistakes. Okay, and actually there's no reason not to print this out right away, if only for test. Now there is a different approach where you can segregate the declaration of variables, all the computations and all the results. So I could also put this in a results area, since the values of min and max are correct. But if I'm writing the program like this, I would like to make sure that this little algorithm here actually works. Yeah, I want to make sure that it works, so I'm going to put a print statement in here. So printf /n to create a new line, and then minimum or lowest temperature equal %g, highest temperature %g. That's the format, and now min and max. And this should work. One always hopes. Yeah, looking good. Actually, it's not much nicer, I think, to have a new line in between here. Okay, so like that. And you can see one glance shows this is actually correct. So this part of the exercise is already completed and works. Now let's do a average temperature computation using another loop. And to do that, we run a for loop, and in that for loop we simply compute the sum of the elements. That was the task in the previous programming assignment, so you should have no problem doing that. You could even copy the code from there. I'm not going to do that. I'm just going to only copy this one line here, and it's only a one-line statement. So I'm running over the loop elements, and then I'm going to sum is already initialized to 0, so all I need to do is add up the elements of the array like this. And I can print that out, but I'm pretty sure that's correct. So now I'm going to compute outside the for loop the average. It's already declared, so average is the sum over the size. And this is another result I would like to print out. Days above average using auxiliary days above average temperature. Oh, sorry, that's not days, it's like actually the average temperature. Sorry, I skipped a line here. G, and the average temperature is ABG. So let's run that. There we are. You may not be able to do that in your head, but it looks good. That's the second part. So completed 2 parts already. Now, unfortunately, in this case, we cannot close them, so I will have to keep going up and down, but I think you probably follow me since there are not that many variables to account for here. So we want to count the days above average using a loop and a conditional statement. So first of all, what is the idea? The idea is that we run through a loop and test every array element, and just like as before we compared with min and mix, minimum and maximum, we're not comparing with the already computed average. And if it's greater than the average, then we're going to increase the counter, which we already introduced here, this one, this counter, which is currently set to 0. So that's the one we need. And if you want to be sure, you can just copy that as well, about the spelling. So let's start with the loop. For I equals 0, I smaller size. I plus plus. This is a multi-line statement. So if the temperature of the current element we're looking at is greater than average, then add 1 to the days above average and close that loop. And now we can print the days above average temperature. So days above average temperature, days above average. And this should also work out of the box. Let's check. Nope. What mistake did we make? Oh, I see. Shouldn't have been a G, it should have been a integer, because we defined it as integer. Now it works. So 3 days were above 80 degrees. The first, the fourth, and the fifth. So that seems to work as well. Okay, let's move on. The last one is modify the array by adding 2 degrees, and I'm like at 2 minutes down to my 20-minute limit, so I hope I'm going to make that. So let's have a little print thing here. Modified temperature, temperatures Monday to Sunday. And this is a loop that goes over the array, and instead of just printing the array, we're going to add an element. So I'm going to copy my loop here, copy the whole thing to save some time, and inside this loop what we want to do is we want to increase the temperature by 2 degrees. So for every element we're going to add 2, and because the temperature is a floating point, it's good to do this in floating point. And then instead of having another loop where we print it out again, we can just print the element as soon as it's been increased. So we can just say %g temp of I, and that'll be the new value. Yeah. And that's it. That's the program without user input. Let's see if it works. There we are. And let's have another, like that. And that's the result. So I'm going to make that a bit smaller again so you can see the whole program. That's basically all we have for the moment. Thank you.